Good afternoon. Today we are going to present you our paper about the role of wind farms in estimating energy demand in a microgrid. The paper is made and presented by PELESKOV Semion,
REchtCANU Ana-Maria-Ruxandra and Mihai REBENCIUC, members of Center for Research and Training in Innovative Techniques of Applied Mathematics and Engineering, University Polytechnica of Bucharest, Romania.
Our paper contains a general introduction into microgrid smart networks, biomimicry in programming, variable distribution in width-speed modeling, a case study realized in Romania, and some conclusions.
Microgrids are nodes of intelligent network smart grid that are usually met in the context of smart city. Principal advantages of the microgrid are:
Energy is produced using eco-friendly sources such as wind farms, solar panels, and hydroelectric power stations. Proposes intelligent energy storage. Energy is never lost as it is being redistributed to nodes that have increased consumption. They are easy to mount, but in case national power system runs into an accident, microgrids are able to work completely autonomously.
biomimicry in programming. New technologies are based on principles taken from nature. In this category, a big part is taken by biologically inspired algorithms, which are the base of genetic algorithm, short GA. It offers a special technique of programming based on creation of programs populations made of codons, which are in fact binary or integer rows of numbers. Genetic programming, short GP, represents a modification of GA based on the principle of the unlimited number of genes, codons, of population individual. Grammatical evolution, short GE, proposes a special modification of GP which consists in the transformation of each individual from the tree-type syntax into the linear-type syntax applying grammar. More about grammatical evolution. One of the main advantages of GE is modularity, meaning that a grammar can be easily introduced in almost any GE, GP. Grammar is always formed of four main types of symbols: N non-terminals, the following to be processed; T terminals, this will be included in the final output; P symbol production rules, and S a start symbol which is mandatory a member of N. At each iteration of the algorithm, population follows procedures similar to ones from GP, more exactly, selection, crossover, mutation, and reproduction. The next symbol in the grammar is calculated by the rule of the remainder estimation. C is the codon value, R is the number of possible choices for a symbol from grammar.
Wind farms require modeling of wind speed distribution and estimating energy production. Variable distribution is one of the best modeling methods, proving relatively small errors. The probability density of the variable distribution has this form, where x mal is a wind speed, but x beta c is a random variable with parameters beta and c of variable distribution. Beta is the shape parameter strictly positive, dimensionless, which evaluates the stability of the wind. C is the scale parameter, strictly positive, measured in meters per second. It is dependent on beta and directly proportional to the average wind speed. With the help of maximum likelihood method, we can determine C in function of beta. The solutions of the nonlinear equation too are determined with Newton's method, applied iteratively, obtaining the estimating values of the two parameters. The analytical equation of wind energy production is used to estimate energy production. P represents the motor power measured in watts. A is the rotor swept area exposed to the wind, measured in square meters. Rho is the air density. Ws is the wind speed, measured in meters per second. Cp is a performance coefficient. Ng is a generator efficiency. And Nb is a gearbox or bearings efficiency.
The estimated value of energy production must be declared to the energy dispatcher to regulate the amount of energy from hydropower and thermal power plants. The adjustment is based on demand, so the value of wind energy production has an important role in estimation of energy demand.
The case study involves analyzing the wind speed and the behavior of the parameters of Weibull distribution on May 5, 2020 for Gombonești commune, respectively the city of Timișoara in Romania. The locations were chosen according to human settlement type, geographical positioning, climate situation, and climatic influences.
Gobanești commune from Botoșani County is located in the northeastern extremity of Romania, having a temperate continental climate with extremely continental influences. The city of Timișoara is located in the western part of Romania, being characterized by a temperate continental moderate climate and sub-Mediterranean influences. Data is taken from open source windfinder.com. Beta is considered a vector, beta belongs to the range 1.5 to 3, which is followed by step 0.01 to interpret and choose the most appropriate value for the proposed climate. The algorithm shown in figure 6 calculates the C scale parameter for each beta in the set range.
Weibull distribution parameters characterize the wind distribution. Thus, the low values of beta correspond to an unstable wind and the high values are attributed to a stable wind. Scale parameter indicates that the wind speed is being directly proportional to himself.
In the graph shown in figure 7, we can notice the dependence of the scale parameter on the shape parameter. Timișoara corresponds to a scale parameter approximately equal to 1.5 and Gobanești commune corresponds to a C approximately equal to 3.5.
Based on these values, it is possible to correspond each C value to a climate zone. Also, we can observe the proportionality between the variation of wind speeds and the scale parameter. In reality, there are many variables introduced by nature. So, for the implementation of GE, we considered three types of variables: I, solar radiation; T, ambient temperature; and P, atmospheric pressure. The estimation of the scale parameter is performed as a function of time, t, and the values of the functions considered at time t minus 1. In this case, we decided to apply grammatical evolution.
Figure 8 shows the three-type syntax diagram that explains the process of generating the formula from the model shown at the bottom of the figure. The grammar we made, implemented with GP, will return evolving the most appropriate formula based on the considered climate. In the box below, we can see few examples of the output of this grammar made with the help of the OpenBNF Playground platform.
In conclusion, wind farms have an important role both in estimating energy demand and in monitoring of the structural health of smart grids. Wind farms play a particularly important role in reducing carbon emissions, as the production of green energy partially covers demand and reduces the use of coal power plants. However, wind farms have several inconveniences. They require estimating energy production and implicitly modeling wind speed distribution, which is considered as a nonlinear control.
About grammatical evolution, being a developed algorithm, GE have almost unlimited possibilities for accurate engineering calculations, including estimating energy demand based on all variables involved in the process. And about the microgrid, we can conclude that it's a modern, developing technology which we propose to improve by adapting of currently existing algorithm to a one using GE-GP for more efficient energy demand estimation. We believe that microgrid will become more and more popular, thus developing the power production industry. We thank you for your attention.